Okay, this next segment is designed to introduce the statistic that we're going to use to assess the relationship between two variables. If you don't have them yet, you might want to pause this video, go to Blackboard, and download 3 handouts. One is called Formula Pearson's R. Formula Pearson's R, that's the first handout, Formula Pearson's R. The second handout is Example Number 1, Calculating Pearson's R. And the third one is Interpreting Pearson's R. I want to begin this segment officially by noting a couple of things. Scatter plots, which we've already been over, are what we can refer to as the graphical display of a relationship between two quantitative variables. The graphical display of a relationship between two quantitative variables. And again, as a quick refresher, when we examine a scatter plot, we can determine if there is a linear relationship, and if there is, we can determine what the direction of that relationship is, positive or negative. And we can likewise get some idea as to the strength of the relationship. Now, Pearson's R, the other statistical procedure that we're going to work with this week, Pearson's R is the statistical or mathematical display of a relationship or test of a relationship between two variables. And in order to conduct Pearson's R appropriately, you really need to know how to calculate accurately a distribution, a sample's mean as well as their standard deviation. So if you're a little bit shaky on that, means and standard deviations, please email me and or go and review the material that covers those topics. I'm going to first refer to the formula for Pearson's R. First and foremost, when we calculate Pearson's R, we are going to be left with a number. That's just like when you calculated a z-score, you found a z-score. And so when we go through the mathematical machinations to calculate Pearson's R, we're going to have when we're all done, we're going to have a number. And once we have that number, we're going to need to know what that number means. We're going to need to be able to talk about that number in order to describe the relationship between two variables. Now, this is the handout, the formula for Pearson's R. And I'm only going to refer to this top formula, what's sometimes referred to as the raw score formula for Pearson's R. And there's a couple of things I wanted to point out that might look a little bit different for you, depending on how up on the material you've been keeping. I'm not gonna start at the beginning on this one. I just want to point out a couple of things. First off, hopefully this symbol. Well, first remember, what's Pearson's R designed to do? It's designed to test the relationship between two variables. That's kind of the point. Pearson's R is used to test the relationship and describe the relationship, if there is one, between two variables. All right? So through our discussion of scatter plots, we've also determined that we're working with two variables we're calling one x and the other y. X is our independent variable, y is our dependent variable. Hopefully this symbol is not new to you. This symbol has been used and will continue to be used to represent the mean for a set of data, the mean for a set of data. In this particular case, though, this is the mean for our x variable, because again, Pearson's R, we're going to be working with two variables. This is the mean for our x variable. This symbol is new, y with a bar over it, but the bar means we're dealing with a mean. This simply means the mean, the arithmetic average, the mean for our y variable. Okay, so mean for our x variable, mean for our y variable. This symbol, at least without this little subscript, that tiny x and that tiny y, those are referred to as subscripts. This symbol, S with a hat over it, that is the standard deviation. It was, is, and will remain our symbol for the standard deviation, but it's very important to pay attention to the subscript. This is the standard deviation for our x variable. This is the standard deviation for our y variable. Relatedly, some of you have been emailing me and asking me questions, and it's helpful when you let me know what you mean. And some of you refer to as, you'll literally say in your email S with a hat on it. It would be great if you would start referring to that as the standard deviation, because that lets me know that you totally understand that when you see that symbol S with a hat over it, that you're referring to the standard deviation. So instead of saying S with a hat, just go ahead and say standard deviation. That way we both know for sure what we're referring to, and I know that you're immersing yourself in the material and getting it. So back to this formula. This number, or this symbol, which will be a number eventually, is the, bless you, Choxy, is the standard deviation for the x variable. This is the standard deviation for a y variable. Now, what might be new to you is this symbol right here, sigma xy, or sigma x times y. What this symbol is telling us to do is to multiply each case's x times its corresponding y. Because remember, pause for a second, remember that in relational analyses, correlational analyses, scatter plots and Pearson's R, we have a sample that has provided us with two pieces of information, a value for an x variable and a value for a y variable. So this symbol here, sigma x times y, is telling us to take each x, multiply it by its corresponding y, and then add them together. All right, x times y added together. Add all those products together after you multiply x times y. And then divided by n. And n is simply the number of cases in our analysis. Not the number of data points, the number of cases. So think back to that scatter plot where there were 38 data points, 38 people that provided two pieces of, in fact, I have it right here. 38 people that provided two pieces of information, how many cigarettes they smoke in a day and how many colds they experience in a year. The 38 people provided us with information on those two pieces of information. However, our n is, in this case, 38, because 38 people provided us with that information. So n is 38. So here, n is simply the number of cases, the number of things or people that provided us with information, equals r. All right, and that's what we're going to end up with, r. And remember, lowercase r, not uppercase r, lowercase r. So this symbol is telling us to first find the product, the summative product of all our x's and y's together, multiply each x times its corresponding y, and add all those products together, divide by n. That's going to give us a number. We'll see an example in a little bit, probably in part 2. And then we're going to subtract from that number the product of the mean for x times the mean of y. And then we're going to divide that whole numerator by the number that results from taking the standard deviation for our x variable times the standard deviation for a y variable. So this is the formula. This is the raw score formula for Pearson's R. Now, we're not going to use the z-score formula, but this is the z-score formula. This will get you to the same result as the raw score formula. However, as you might guess, in order to use the z formula, you have to do a couple things first. The first thing you have to do is convert each x score to its corresponding z score, convert each y score to its corresponding z score, multiply those z scores together, add up all those products, then divide by n, and you'll get the same result. Now, if you want, I certainly would encourage you to test out the z formula and see if I'm right, that you get the same result. I'm going to walk through an example in a second part to our introduction to Pearson's R, a statistic that's designed to assess and describe the relationship between two variables. So back in a moment.